years. So this is a condensed version of the courses I teach in AI, machine learning, advanced machine learning, natural language processing, those at Northeastern University. Here in Silicon Valley, we have a campus of Northeastern University. Prior to that, I taught the same in the University of Washington system. So I will provide an introduction of these two workshops, first with a title and abstract, and then a more detailed overview using PowerPoint. Yeah, Lena, would that work?
Yeah. You
Or
can share your screen.
yes, I'm doing that now. So this will stop other screen sharing. That should be okay. So here, team, these are two different workshops. And because I'm a practitioner and a professor of practice, I bring that twin points of view. My work is I'm here in the Valley, a VP and distinguished engineer at MindBody. It's a leader building technology for fitness, wellness, salon and spa, the beauty industries. So the first workshop is a longer workshop here. This is AI, machine learning, natural language processing for enterprise and public sector applications. This one is focused on the core concepts of these three bodies of knowledge, an introduction of it. It's a 4-hour workshop, and then the algorithms. So the concepts part of it is overview of what they are, theory, and explanation of about 12 algorithms total, 12 algorithms total, which map to machine learning, classical machine learning, an introduction to deep learning, similarly, introduction to artificial intelligence, and natural language processing as well. Those four, as you probably already know, these, along with AR, VR, and robotics. For completeness, I'm mentioning all of them. This is a course set or knowledge set that is defining the future of technology and economy. These are again classical machine learning, deep learning, AI, natural language processing, artificial reality, augmented reality, virtual reality, AR, VR, and robotics, which is mechanical automation. These are all related. And getting an introduction of this, ideally it should be with machine learning. That builds on mathematics, statistics, what we call data science, what used to be business intelligence, those builds on that classical machine learning, then into deep learning and so forth. So the importance of this is very clear. In fact, that is my second workshop. Let me quickly allude to that. That is valuation, bridging the last mile value gap, and how do we actually argue for deriving value from AI, ML, NLP, and what are the blocking issues in this very exciting and high expectations new technology area, right? It's supposed to add about 15% to the total GDP, about $15.5 trillion by just next 9 years, 2030. So I go into great detail in this valuation workshop. It's a 2-hour workshop. The intent of this workshop is it is meant for engineers, data scientists, program managers, product managers, CXO, CEO, CTO, VP, and also venture capital investors. Similarly, government, there's a lot of public sector activity these days in multiple countries. Governments aggressively investing in AI and automation. So for both private and public sector professionals, this second workshop is focused on what is the value of this AI and ML? How do we bring it to bear on workflows that are existing and what are the blocking issues in our building and shipping effective AI and machine learning products. And if we are successful with that as startups and government and private sector, what are the benefits and how do we actually show the return on investment to our sponsors and so forth. So this is the second workshop. It is 2 hours long and a day or two later after the first technology focus workshop. So at this time, I will switch to the details of each of these workshops using just a PowerPoint slide each, but I'll be explaining that in detail. Before I do that, any questions from any of the participants? Introduce myself for the attending audience. That's Mohan. Mohammed is saying that. So I've already done that, Mohammed, right? So if you have any questions, please feel free to type it in the chat, and Alina will make sure that they're answered. So the abstract here, what we are saying is that it is a hands-on workshop. Python is what we'll be using. PyTorch and TensorFlow introductory for deep learning, NLTK for natural language processing, OpenAI for one algorithm that is focused on AI, and then the rest of it is machine learning, classical machine learning, which is your scikit-learn and other Python libraries. That is what we are going to use. The goal of the workshop, that first workshop, is to provide an early career executive or data scientist, machine learning engineer, big data engineer, program manager, product manager, a thorough first introduction of what is machine learning, how is it different from deep learning, what is the difference between AI and machine learning, what is AI, why is natural language processing important, and why is it a part of AI, what is it? Hmm? So those that is going to be the focus. There seems to be a question here. Explain more the relation between Q learning, AIML. All right. Yeah, today's session, Kiran, today's session is only a talk introduction about the February workshop. It's not the workshop. And I will be going over technical topics, but only to give you like a table of contents, what I'm going to teach in the real workshop. That's what we're going to do, Kiran. Yeah. And Q learning and other branches of AIML, that's a good question. So here it is. Uh, yeah, sure. So here is the difference. Reinforcement learning is a branch of artificial intelligence, AI. Yeah. And it is very crucial for AI actually, more so than machine learning. Q learning is an early module and a sort of a first introduction within reinforcement learning. The difference between machine learning and reinforcement learning is like this. First let's talk about machine learning. Let's do that. Yeah. So let me go to my slideware, just this one, and let's there. Let's stay focused on that. Now I have 12 algorithms, not 8. But machine learning means there's a machine and it's learning. What is a machine? Machine, it starts as a Turing machine, the theoretical machine, Turing automaton. Yeah, this is like a state diagram. There are states and there are data inputs into states. So that is the abstraction for software. Take a piece of software, Gmail, Microsoft Windows, Word, Excel, any number of software, web apps, and so forth. Those are machines. A server is a machine, a sensor is a machine, a watch is a machine, your cell phone is a machine. These are all machines. With the Internet of Things that is coming, the ubiquitous computing, the world is going to be full of connected machines, things, intelligent things, robots. So all of these are machines. But the traditional machines are not learning machines. You program them to do something and they keep doing that. Excel, you build something, you provide the input, it's giving you the output. That's the machine. Yeah, all your software are like that. Machine learning has the ability to learn and improve. So it goes and looks at training data repeatedly, gets additional rows, additional features, additional columns, and relearns and does better. So what is learning in our regular day-to-day definition? Learning is doing the same activity, but doing is better the next time and better and better. So I'm going to be teaching that type of learning using what are called data frames, data sets, how to each of these algorithms, k nearest neighbors, k means clustering, one rule, association rule mining, outlier and anomaly detection, decision trees, neural networks, recommender systems, support vector machines. Yeah, and then we move to NLP text mining. So now to answer your question, Mohammed, Q learning, reinforcement learning, there is no data set that you're giving, no training data that you're giving to the robot, to the agent. Instead, the agent launches into life, just like young people do. Like you send your young daughter or son to a different town, a college town, a different place. Or when you're young, you go somewhere, you take up a new job, then you learn, you figure it out. You do some activity, there is a reward or punishment. If you done something well, then you win something, you're rewarded. If you do it poorly, then there is a punishment, negative reward. We set up in Q learning, in reinforcement learning, that kind of a reward and punishment structures to teach the agent learn and do better and better. That is a very different approach from machine learning. I'm not going to be teaching reinforcement learning in this 4-hour workshop. Okay, did that answer your question? All right. Yeah. So now let's continue with, okay. So here, well. So those are the algorithms that I mentioned. So you got a flavor, right? So certainly the full landscape of important classical machine learning algorithms, including unstructured or rather unsupervised learning. We have prepared Python lab for each of the algorithms. That's what we'll be using. Ahead of that, I'll be teaching how each algorithm works, the mathematics of it, the intuition about it. So that is that. Similarly, natural language processing, what does it do? And introductory algorithms about it. Similarly, AI. Certainly, a survey of algorithms of AI, but one algorithm where it is actually implemented. Yes. So that is the nature of the workshop and the objectives when you complete it, the workshop. What you can expect is that you would have understood what these 4 areas are, how they're related, but how they're very different, and how does it all come together in the context of robotics and artificial intelligence? How do the core algorithms work? How to use Python-based programming to implement basic algorithms and get started so that later you can continue your learning using the same libraries and 1 or 2 good books. That is, and also the ideas for practice, in your projects, work, and so forth, how to convert a given use case, say sales, leads prediction, or healthcare, emergency room admissions prediction, or finance, fraud detection, fraud, waste, and abuse. you have a need like that. How do you actually convert that into a machine learning project application? So defining features, feature engineering, construction of data sets, and then deciding what algorithms you can use, what libraries and packages you can use, and how you're going to run into difficulties when it exceeds certain scale and becomes big data. I won't be teaching big data platforms in this workshop, but that. So as a practitioner, you'll gain the intuition and early confidence about application of machine learning, deep learning. Also, the other one, finally, when to use deep learning, when not to use deep learning. Yeah, uh, understanding of that nature. So that is where I will exit with this introduction of my AI ML workshop. Now I'm moving to the valuation workshop. Okay, and I'll leave some time for questions here. So let's move to the other slide deck. So in the meantime, if you have any questions, please type them up or raise them.
Yeah, we have one question, Prasad.
Yes.
Anonymous is asking, after attending your workshop, what else should I do to become a AI or ML engineer and become an expert in this area? Some resources will
What,
be very helpful. It is posted
yeah,
in the Q&A. In
yeah, I'm looking for it, but I got it from you, Lena. Yeah, so here, team, here is an insight about your question. This is a very exciting, very happening space. There is a plenty of opportunity for skilling up and seizing the opportunity. This is true. Public sector, private sector, non-profits, everybody's interested. Yes, while that is the case, here is what you would need to do. One, learn the technology. Two, learn where and how is it value, meaning revenue value, ROI, and addressing a use case, an actual pain point today in your respective industries. You would need to watch for that also. You need to kind of conduct these two in tandem together. That's my one guidance point. And second one, after this workshop, if you are interested and motivated, I hope you are, then you pick up, I'll give you a short list of books that you can pursue. One thing that this workshop will help you is there's too much out there. There's so much out there. You tire yourselves with all the books and the blogs and everything. Yeah. So not to do that, just pick two or three good books. ISLR, Hasty Tip Shirani, that's for the concepts and theory of it. Okay, Ian Witten, a good solid introductory book. Just those two for your machine learning. Yes, and then one good practice book. I can recommend what that is for you. Pick it up and continue coding program. Yes, yeah. Why that I'll share it with Lena. We'll run out of time here if I type all that here, Kiran, at this time. But I'll be sure Lena will certainly share that with you. I'll share it with her.
yeah, I'll do it.
Okay. All right. So that is how. Then so you contain your effort like that. You focus like laser focus, and within 2, 3, 4 months, you would have gained your confidence. And then you launch into an actual job or start projects in your own current job. And about 70% of effective learning for us professionals happens on the job. You see, so that's my answer to that question. Now let's move here. I have 6 minutes left here. So this is the valuation workshop. Yes, so I'm sharing my screen back. This one, valuation of the AI/ML enterprise investment. Now this is please where strategy, CEO or economics hat. Yeah. So why is it necessary? See, there were what are called AI winters. AI winter means there was a lot of excitement, 60s, 70s, 80s. Then investments were made. AI made a lot of promises, but it could deliver only partially. So fundings were withdrawn, and there was AI winter. I mean, there was not much activity at all with AI. Then it came back again. Now it's coming back full force. So we as professionals need to be careful about two things. One, deliver value. Two, make sure your algorithms are ethical, right? The ethics of AI ML, big, huge topic. That's a separate workshop altogether, privacy, ethics, and so forth. So this is about value. Macroeconomic value, I explained a bit of it, right? If you look at the investment growth of funds, AI funds are really taking off in their return on investment compared to your S&P 500 or your Dow Jones and so forth. That is there. Now, micro level valuation for your individual project that your leadership is funding for your AI ML, where is the value? What are the methods? Those valuation methods are missing. So this one is a detailed workshop. It is based partly on Dr. Aswath Narayanan. He's a very reputed valuation expert on NYU, Stern School of Business. So I refer to his work as I build this for our workshop. Why do we care about valuation? If you don't deliver value, your project is going to shut down in 1, 2, 3, 4 years like that, right? So there are some bottlenecks for AI. First of all, where do you discover value? Recommender systems, chat bots, marketing campaigns, and so forth. I'll be teaching about them and the ROI of it and how you can articulate that to your leadership and your sponsors and colleagues and so forth, and how to deliver that value. Gartner, what is AI value chain? How do you pick and choose your projects or your career time investments? And then what are the blocking issues? How do you set up startups for good valuation with AI ML? And rigorous actual algorithms, methods for assessment evaluation. When you go public, IPO, or when companies merger acquisition, how is that valuation actually done? How come LinkedIn was what, some $36 billion Microsoft paid for that? And today, Microsoft's total value, 90% of it is what is called intangible value, meaning you cannot find it in cash flow and books, accounting books, and so forth. So AI ML value is largely intangible value. What is that? So this is what I'm going to be teaching with this valuation workshop. Both of these are important for professionals like us. That is where I'll pause today's introduction, Lena. There are some more questions. IDE would be, your Jupyter notebooks is what it is. And
what are the standard and norms of the best practices for development or programming with Python language?
Oh, I see that. Well, Python itself is much bigger than the machine learning Python, right? So one thing I will say is, again, Python itself is like a big ocean, right? Not to pick up too many books, not to get discouraged or overwhelmed by multiple books. This is like rule number one, I would say. Yeah. And then I can recommend one good book, Python. In fact, Python for machine learning. There are books like that. Even among them, there are bad books and there are 1 or 2 good books. So that is what you would pick up. And when you start practicing coding, you would understand, if you're a new programmer, some 70% of it, not to be discouraged by that, but keep going. And slowly, iteratively, you'll get comfortable with that. That's what I would say about the Python piece. IDE is Jupyter notebooks. All right. So let's then, I'll pause it here and take your leave. Yeah, Lena.
Yeah, okay. If any questions, you can share your email ID, or I'll share with you the question so that you can answer later on.
Yes, I'd prefer that. Yes, sir. Thank you, team. Thank you, Lena. See you, Chanchal. Bye.
Thank you, Prasad. Bye.
Thank you.
So now, so we have Chanchal Chatterjee. Hi, Chanchal.
Hello, good afternoon, good evening. If somebody is further out. So I'd like to let me bring up the Q&A and the any more chat window. So can you see my screen?
Yeah, right. Able to see the screen. Right.
Awesome. So my talk, I'm not giving a workshop, I'm giving a talk, and it will be slightly different topic. It will be mostly on MLOps.
Chanchal, just introduce yourself.
Oh, okay. Yes, sorry. Yeah, my name is Chanchal Chatterjee. I work for Google Cloud. My job is program management of customer projects. So I have done many projects at Google. I have been here 3 years for many types of customers, and they're all ML projects. I'm an ML program manager. I deal with many customers solving machine learning projects, from financial services to healthcare to manufacturing, all kinds of different customer topics. So one of the challenges that I have seen is that most of the time, either the customer or any third-party services, or even within Google, you can come up with a very good algorithm. But the problem is how to take an algorithm and make it into production, take it into production. A huge number of machine learning projects do not see the light of the day because you have a nice little algorithm in a Python notebook, but you don't know what to do after that. So my talk will focus primarily on that, is trying to establish a methodology. It is not 100% fully formed, but it's a very good start. So the topics that I will cover are basically the vision of the project, that is, why do you need to do this? Second is I'm going to give you two templates. One, I'm going to release at the talk, and I'm going to give you a short demo. The second is open source. It is already linked with this deck. You can already see that. So the first one is how to take the different building blocks of machine learning and put it together in a Python notebook. This is from starting from your project, from your use case, and how to put it together. The second step is how to take that and make it into an end-to-end ML pipeline. Those are the two steps in order to take your idea from basic concept to production. I'm not going to talk about any depths of machine learning, like what type of algorithm, what type of methodology to follow, or whether to use deep learning or machine learning, scikit-learn, XGBoost. I'm going to basically start with the idea that you have the basic knowledge to create an algorithm, but you don't know how to take that into production. So let's start with the basic vision. Yes, my presentation will be GCP specific, but you could take this concept and make it work with any other platform. So you could also, Google offers something that is open source, is called Anthos, which will also allow you to take an implementation on Google Cloud to move it into any other platform, including on-prem, to build a hybrid cloud solution. But I'm going to stick to the Google Cloud for simplicity's sake, but you could take it to other clouds. So a basic machine learning pipeline looks like this, that you have different types of data that is coming in, whether you're coming in from a live source, which in the Google Cloud terminology is called PubSub, which is sort of a RabbitQ type implementation. It can be Kafka. The second one is that you have a storage, some kind of a block storage in Google Cloud that is known as GCS. And the third is a tabular storage, which is in Google Cloud, which is a data warehouse called BigQuery. Then ingesting the data from any of the sources, you want to do a data preparation. You can do hyperparameter tuning or skip that step. You want to do model training. Then you want to deploy the model into a model repository so that the model is properly labeled and versioned. You want to explain the model for global explanation, and you want to do a prediction. Yes, I'm going to share the slides. So the second, so in all of these, you want your solution to start from your use case. That is, you are a smart guy who has come up with a hot idea, of how to solve your use case. Let's say your use case is to find, read a document with an NLP algorithm, or your use case is to find fraud in transactions. Okay, so you have come up with a cool algorithm. So you start with that, and you have written it in a Jupyter notebook with your code, with your data. Okay, you want to take that algorithm and you want to deploy it easily. You want it to be scalable, so that today, if you have 1,000 samples coming in, and tomorrow you have 10 million samples coming in. How do you scale from 1,000 to 10 million? Okay, it should be composable. Is there a is there a demonstration in the training workshop? I'm not doing a training workshop. I have a 1-hour talk, and I will try to squeeze in a quick demo. Okay, I'll see how much time. I have put in 2 demos in the slide deck, but I don't know if I can make 2 demos. Okay, the third one is composable. For example, if you want to take out the hyperparameter tuning, you could put the prediction on-prem, and you could do the rest of the pipeline in the Google Cloud or any other cloud. You want it to be orchestrated. Orchestrated means that you want to schedule a certain time when you want to do the training. The training could be initiated on an input from data. It can be initiated by user, or it can be initiated at a certain time of the day. There are many ways to schedule it. Okay, and then it should be secure. Nobody else should be able to get in. And you should be able to port it into other platforms. So I'm going to talk about a 2-step process. The first step, I'm going to share with you a Python template. This is a notebook, okay? I can even call it a Python notebook, okay? A notebook template. So this is where you have a cool notebook like this Jupyter notebook that I have over here, and you write your code, you create a very nice model. So mine is a very simple model for demo purposes. And then once you have this notebook, you start from your use case, you have your essential cloud infrastructure, and you have a technical know-how to build the model. So then once you build that model, you want to go to a stage where the model has an acceptable performance. So this is first one will deliver to you a model of acceptable performance. The modeling pipeline is tested in a Python/notebook template. Okay, and you have internal teams that are ready for deployment. Okay, so the second one that I'm going to talk about is more open source. Is once you have that in a notebook, how do you take it and make it into a pipeline so that you can create a scalable, composable, deployable, and a secure solution? So that's the second step. So it's a 2-step process. Make sense? Okay. Does there is an attendee certificate for the candidate presents? I absolutely didn't understand what it means. Okay, so the objective is to automatically deploy your model, allow you to build your model step by step, integrate that with the pipeline, create a scalable, composable, secure solution, and to demonstrate the steps in the migration process. So the ML components, the units of the ML pipeline we are building, we are implementing. Component means a unit of the ML pipeline. So data ingest and pre-processing, hyperparameter tuning, model training, model deployment, model prediction. It can be a batch or online. And then there's a model explanation or a training orchestration. Okay. So let's talk about the first one, which is the Python/notebook template. Okay. And this one is a cool example. And this notebook that I have over here is the template. idea is to, what we are going to do in this step is to implement, build and train the models. We'll deploy the model into a model repository. We'll do the prediction of the model, and we'll do the explanation. We are going to put them all together for a single use case, and we are going to test all these modules. That's the first step. What we are not going to do is to build an ML pipeline and orchestrate the pipeline. So the first step, which is this step, we are going to build all the key pieces of an ML pipeline, and we are going to test them in a notebook, but we are not going to orchestrate or build the pipeline. Okay, that's the second step. So this is where we are prototyping the model. So the key modules that we'll be building in this step are how to build a model, that is ingest from stored or live sources, pre-process the data, and build the ML model. This module will also be used to train the model. Okay, we can also do regular training or hyper training, hyperparameter tuning. We will deploy the model into a repository. We'll do online or batch prediction, and we'll do model explanation. So these are the building blocks of the model. Delving a little bit deeper, we are going to build distinct files. These files are going to be like inputs.py, model.py, setup.py, deploy.py, train.py, train hypertune.py, and predict.py. Okay, so examples of those files are given in this demo. I don't know how much time. So this is an input.py, which basically loads the data from a repository. This is a model.py. I have a very, very simple model with a variable depth, with a variable learning rate, with a custom loss function, or a custom metric. This is our hyperparameter tuning function, and this is our training function. All these things we are going to build in this step so that you can easily test all the pieces of a machine learning model. So data preparation will be done in input, ingest and preparation would be inputs.py. Your hyperparameter tuning, this is actually reversed. Sorry. This will be hyperparameter tuning. This will be training, and this will be deploy. This will be explain, and this will be predict. So we can build all these pieces, and we can call them one after another to make sure everything is working right. So that's the first stage. Any questions at this point? Okay, so the next one is going to be, one second. So the next one is going to be how to take these building blocks and make it into a pipeline. So for that, we have a neat little open source code, which is called the pipeline generator. It implements the whole pipeline in a very simple steps. On your GCP account, unpack the Git repository, set up the user parameters in a config.yaml. Okay, you can provide the model and the pre-processing code that you have built in this step. You run the library code, and it automatically builds the pipeline. Okay, so what is this? It could be K-fold cross-validation. Yeah, you can include that into your model training process. So basically, you set up a simple config file. You put your link to the model code. You can actually put the model code here, or you can just put a model.py file, which you have built in the previous step. And here's an example of a scikit-learn model or a TensorFlow model. And it will automatically create the pipeline. But you can generate the pipeline by simple Python code like train component, deploy component, predict component. You can add these components, and it will create a very nice Kubeflow pipeline. So, so here's the open source code, which is in the GitHub. It's called ML Pipeline Generator. I kind of rushed through this section. And I'm going to offer a quick demo of this step also to show how you can build a model from a concept that you have built in the previous step in a Python notebook, and you can create a nice pipeline out of it. I can do a TensorFlow-based demo, model demo, and a Kubeflow pipeline demo. So that's basically what I have to present in this 1 hour talk that I'm going to give. So I plan to do like a 20-minute slideware presentation and like a 40 minutes of demo. So today I spoke for almost 17 minutes. So that's roughly how long I'm going to speak. I can speak a little bit longer to explain these topics, but that's basically the idea.
Yeah, and also
any questions?
I posted all the links for the event in the chat. So you can check the agenda, you can check the registration page and the other details of the event.
Yes, and then yes, you could try the demo yourself. There is an open source code that is linked over here. Here I've given the GitHub location and ML pipeline generator. This is the GitHub. You can actually, sorry, I was inside the code. This is the ML pipeline generator GitHub. It's under Google Cloud Platform, ML pipeline generator Python. That is the name of the repository. So yes, you can try it yourself. And regarding this part, we are going to probably give you a notebook as an example. It won't be part of the GitHub, but I'm probably going to email you a notebook or whatever. Eventually, this part of it would become an open source, but it is not an open source yet. Okay, any other question? I don't see too many questions coming up.
I think
okay.
No questions. We'll just wait for a couple of minutes. So Govind is asking one question. Chanchal, is there any specific?
So no, I'm not going to focus on a specific type of modeling. I'm going to focus on, given the fact that you have built a model, how do you take that model into production? I'm more going to focus on the practice of machine learning rather than the research of machine learning. So how do you make your machine learning idea into a practical solution? So I'm more on the practice side rather than on the concept side. Will you be able to address the upfront and ongoing costs? So you can, you probably, I think it used to be that you could get a $300 free GCP account and for 1 year. And so with a free pass, you could do this. Everything that I've described here can be done well within that, because you don't need any GPU or anything. You can do a single 16 CPU or 32 CPU to build the model. So you could test all of this out practically for free. If we already have a data pipeline framework and have ML jobs and regular Spark jobs running, what can we introduce new among the blocks you talked about? Okay, so if you have a data pipeline, that is basically the first piece of this. It is not an ML pipeline. So the data pipeline is how to ingest the data rather than do the ML. So you could put an a Spark-based processing in here. As Databricks also has something called ML Flow, but Kubeflow is very different. What we are preaching here is Kubeflow, and Kubeflow is open source. You could do that for free. You don't have to pay for additional software. You just need the GCP account where you can get a free account for a year and test it out. So yes, you can integrate Spark-based processing here. I personally haven't done that, so I'm not very familiar with it. But yes, a lot of my customers have Spark-based processing in the data preparation phase. Fit in an AWS-based infra. It should. My example is very GCP specific. You'll have to take out the GCP constructs and replace them with AWS constructs in order to make it work. So that's work on your part.
Yeah, and Chanchal, and your talk will be on 23rd. You can.
Yes, my talk is at 23rd at 1 p.m. PST. So 23rd, 1 p.m. PST, please attend. I would love to give you demos as much as possible. I think the Jupyter Notebook will be hard to demo in 1 hour and give the talk. I'm going to probably demo the pipeline generator and show you how a Kubeflow pipeline is created out of the concept. I'm probably going to take the Jupyter Notebook, divide it up into blocks, and just quickly go through individual blocks of code rather than run it. And then pass on the notebook to you for future use.
Yeah, we have one question, Chanchal. Can you please take it?
Yeah, model explanation. So remember the previous speaker talked about the idea that the models should be responsible, that we should do responsible AI. So model explanation basically looks into the model and try to discuss what are the different explanations within the model. Like if you built a deep learning model, let's say TensorFlow-based model, and if you are doing, the example I gave is loan delinquency. So if you go and do an explanation and you find out that you have picked people of, if you have any bias in the model, if there's gender bias, race bias, or any demographic bias, that would be bad. If you also you want to know what are the criteria on which a certain decision was taken. If you're rejecting a loan for a person or reducing the amount of loan, you want to know what is the cause of it. So the explanation has multiple audiences. One audience is the consumer. That's where all this bias and all these things come in. The other audience is developers. You also want to know what are the key features it picked up in order to come up with the modeling answer. So you could use that in order to build a better model. It could also be a report to the management. It can, in the financial sector, you also have regulators, and you could also put in, you can also use the model explanation results to create a report for regulators. So multiple audiences for model explanation, but I'm not going to get into that. That's a lecture by itself. So I'm just going to talk about a global explanation that you can do with a simple model.
Okay, thank you, Chanchal. Thank you for your time. We'll wrap it.
Awesome. If there's no more questions, this is basically what are the pipelines CI/CD to deploy an ML model? Yes. So I'm building the model based on Kubeflow, which is based on GKE, which is a Kubernetes cluster. So you can use the GKE CI/CD. Google Cloud offers something called Cloud Build. You can use Jenkins. So please understand the ML pipeline and the CI/CD are two different things. ML pipeline is putting the components of the ML processing in a pipeline. This is not a CI/CD. This could be orchestrated. So here's an example of an ML pipeline. Okay, orchestration means that when to schedule the pipeline to do the training and all that. But CI/CD is basically to take the entire pipeline and deploy it in your infrastructure. Okay, and how to maintain version control, upgrade, all those are part of CI/CD. And that can be done with your favorite CI/CD like Jenkins or Cloud Build or whatever you have. Can you automate the pipeline processes? Yes, you can. That's the whole idea of the, well, building the pipeline is manual, but what we have tried to do is to make it less manual so that you can do it with the simple 4 steps as we have claimed here. So these are the 4 steps. That is, you unpack the Git, you set up a config file, okay, and you just run the code in 2 steps and the pipeline will be built. So that's how the whole pipeline is built. The first section where we are doing the Python notebook template, you manually code individual pieces, but we are providing the template. For example, you find what parameters to parse. You can use your parameters here. You can write your code here. Okay, but then when you call it with a automatic training process, okay, then this portion is common. This portion you don't have to redo every time. So this one is more of a manual process of building the code that is suitable for your use case. Once all of this is done, then building a pipeline is a simple 4 steps as we have outlined here. Okay, is it possible to add microservices tests? So each of these are actually microservices. So all of these in the machine learning steps are microservices. And these are basically Docker containers. They will become Docker containers, and you can test each of these steps individually. Yeah.